same atomic number but different mass number are called isotopes. Mean that is their atomic number that should be same but mass number that should be defined. That is 1h1 and 1h2. Means that is their proton number that should be 1 1 in both of cases, but their mass number that should be defined, that is 1 and 2. Next we come isobar, means species with same mass number that should be same but defined atomic number. Mass number means sum of proton and neutron number, that is called mass number. As per example, 18 argon 40 and 19 K 40, their mass number that should be same, that is both of cases mass number is 40 but their proton number or atomic number that should be defined, that is for argon that is 18 and for potassium that should be 19. Then we come isotone. Isotones means species having same number of neutron. Neutron is a particle that should be present in all of the atoms except hydrogen. For on the exception, you can say that is hydrogen is only the exception where neutron is not present. Otherwise, in all atoms there should be neutrons is present. And neutron is the species which having the same number of neutron but their proton number or maybe mass number that should be defined. That is proton and neutron number that should be defined. Sorry, proton and mass number that should be defined, but neutron number that should be same, that is 1h3 and 2h4. In both of the cases, mass number that should be different, and their proton number that should be defined. But there, if we subtract it, that 3 minus 1 2 and 4 minus 2 that should be 2. Both of cases neutron number that should be same, that is 2. Okay. Isodiaphores. Isodiaphores that should be species with same isotopic number. Their isotopic number that should be same. That is 19K39 and 9F19. That is must be their isotopic number that should be same. Okay, next we come isoelectronic. Species which have same number of electrons. As for example, Na plus and Mg2 plus. If we consider the number of electrons that should be same. That is Na plus. Na having 11 atomic number. Okay, means in every atom there should be same number of electrons and protons that should be present. So for Na plus there must be 11 electrons and for Na, only Na, there should be 11 electron and 11 proton. Now if Na converted to Na plus, there should be 1 electron less, so 10 electron. In Mg2 plus, if we consider 2 electron less from 12 electrons which are present in magnesium, so we convert Mg2 plus. So they are also 10 electrons. So both of cases Na plus and Mg2 plus, there should be 10 electrons each. Then we consider isostar, the species having same number of electrons and atoms. That should be atom number and electrons number that should be same. For example, N2 and CO. There should be the number of electrons and number of atoms. For each cases, number of atoms that should be 2, and if we consider their electron, total electron, there should be, that is also same. We have to draw MO, or we have to draw their electron in configuration, then we can consider their electrons that should be same. Now we come some relation. As per example, Et equal to NH nu. That is, H is the Planck's constant, that is value is 6.63 10 to the power minus 34 joule second. E is the energy of photon or quantum that which are absorbed, and U is the frequency of emitted radiation. If some amount of energy that should be absorbed, there should be chance of some energy that should be emitted. Okay, N equal to number of quanta of particular energy. If there must be always, when you studied photochemistry, you always know there must be some amount of energy that should be absorbed, otherwise chemical reaction or photophysical reaction does not participate. And there must be the amount of energy that is are called quanta, and that is N is the number of quanta which are particular energy that should be absorbed, that is Et equal to N H nu. H nu is the measure of energy. You can say E equal to H nu. Okay. Then we consider photoelectric effect. Photoelectric effect, that should be equal to Ke, that is kinetic energy, plus H nu 0. H nu 0, you can say that they are work function or W0. That is nu 0 is the threshold frequency, that is minimum frequency of the radiation, that is minimum frequency which must be we have to give, otherwise photoelectric effect does not occur. And work function W0, that must require minimum energy of radiation. Okay, so half mv square means that must be kinetic energy, and kinetic energy H nu minus nu 0. That is kinetic energy of ejected electron, H equal to nu minus nu 0. H nu minus H nu 0, that is kinetic energy of ejected electron must be, ejected electron means which electron that should be emitted. Now we consider that is nu equal to frequency of incident radiation, which that should be incident, and nu 0 equal to threshold energy, that is the minimum frequency to emit the electron. So what the background behind photoelectric effect? There should be, it must be derived that any metal which having their free electrons in surface, or they having the free electron evolving phenomena, some incident radiation that should be in incident radiation that should be that should be there in metal, provide some incident radiation that should be provided to the metal surface. Then minimum amount of energy or minimum amount of frequency that should be needed to overcome the ionization energy of for particular electron to go from metal surface. Okay, means some incident radiation that should be fall upon metal surface, and there must be some energy that should be absorbed, and that's why some electrons which are valence electrons, they are ejected from the metal. This phenomena is called photoelectric effect, because due to photon or due to some incident radiation, these all of the things are occurred. That's why we call photoelectric effect. Okay. Then we consider Bohr model. Bohr model is nothing but MVR equal to NH by 2 pi. NH by 2 pi, that is where del E, that should be equal to E2 minus E1, that is the energy difference, equal to H nu, or equal to, we can say, nu in terms of C by lambda. As we know, C, that should be the velocity of light, equal to nu lambda. Okay, so nu equal to C by lambda, that is Hc by lambda. Okay, del E equal to E2 minus E1, that is the energy difference, equal to H nu. H is the Planck's constant, nu is the frequency, and that should be Hc by lambda. As we know, nu equal to C by lambda. So what go behind Bohr's model? Bohr's model that should be described our orbital diagram of each atom, basically for hydrogenic atom, which can be described as there must be lots of concept, as for example principal quantum number, azimuthal quantum number, and their orbital diagram, that is spherical or elliptical, and they are spread, how they are bigger. So many concepts that should be derived from Bohr's model. Okay. Bohr's model is simplest form. Basically we consider hydrogen and hydrogenic system. As for example, we can derive lithium, that is for helium, which can we derive the lithium to helium by electron revolving or electron removing. We can get hydrogenic system. Okay, by removing some electron. Okay. Then En equal to minus 13.6 Z square by N square. Z is the atomic number. N is the number for integral number. Basically 1, 2, 3, 4, so on. Okay. For you can share, that is principal quantum number, that is changing 1, 2, 3, 4. So by this changing, N also changing. Okay. There must be question that should be mentioned, that is N, that is the principal quantum number is 1, and there must be lithium plus Z equal to corresponding for lithium plus, that should be derived. By this way you can say that is En equal to minus 13.6 Z square by N square. If you put value of Z and value of N, you can derive the value of energy. Okay. You can also say that is del E equal to minus 2.178 10 to the power minus 18 into 1 by N1 square, that is must be lower energy level, minus 1 by N2 square, that must be upper energy level, into Z square. Z mean atomic number, joule per atom. Okay. There must be lots of regions are there, series are there. There must be considered, if we consider one principal quantum number region to other, if electron jump there, and then again it go ground energy state, there should be some energy that should be evolve, some energy that should be evolved. As for example, if N1 equal to 1, that is 1, first energy, first excited, first ground state, for to form 2, 3, 4 that is energy state. If electron goes, then that is 1 means what? That is ground energy state. 2, that is N2 equal to 2, 3, 4 and so on. Higher value also can be permissible. On that case, the series that should be observed, Lyman series, and region that should be goes UV. Okay, energy that should be higher UV. And then if then N1 equal to 2, N2 equal to then 3, 4, 5 higher energy state. So that is Balmer series, that is region basically visible, that is must be gear. Okay, that is 7 colors are observed. We know that. Then N1 equal to 3, that is N2 equal to 4, 5, 6, so on. Then the series is Paschen, that is region is IR, infrared. That is must be N1 equal to 4, that is N2 equal to 5, 6, 7, that is must be series is bracket. That must be region is IR. N1 equal to 5, N2 equal to 6, 7, so on, region that should be far IR when phone series is observed. Okay. N1 equal to 6, N2 equal to 7, 8, 9, region is far infrared, that is series Humpy is observed. And you know there is nu bar, that is must be wave number, that must be called 1 by lambda. Even nu bar and nu, that they are not same. If we consider nu, that should be c by lambda, and nu bar equal to reciprocal of lambda, that is must be 1 by lambda. Okay. So nu bar equal to r z square 1 by n1 square minus 1 by n2 square. That is n1 equal to 1 to so on. N2 equal to means if n1 equal to 1, n2 equal to 1 plus 1, 2. If n1 equal to 2, then n2 equal to 2 plus 1 or 2 plus 3, 2 plus 2, so on. That should be N2, that should be greater than 1 from N1 always. Lambda equal to wavelength, R equal to feedback constant. The value of feedback constant that should be set, that is 109677.8 centimeter inverse. There must we know from Bohr's model, MBI equal to NH by 2 pi, we can derive it, that is if K shell, there must be every principal shell that should be divided, K shell, L shell, M shell, so on. If n equal to 1, k equal to 1, that should be circular shape. As we know, that is 1s orbital, that is K shell. If n equal to 2, k equal to 1, 2, circular L shell. If n equal to 3, k equal to 1, 2, 3, that should be elliptical M shell. N equal to 4, k equal to 1, 2, 3, 4, that must be elliptical N shell, and so on. Then we consider de Broglie equation, that is de Broglie hypothesis. De Broglie hypothesis give us the idea of wave nature of particle. Photoelectric effect, that should be give us the idea that electrons or electrons, that they are particle nature. But de Broglie hypothesis give us the idea of wave nature of particle. Okay, so actually electron having both character, electron having as well as electron having particle as well as wave-like nature. Okay. De Broglie equation, lambda equal to h by mv. mv is the momentum, h is the Planck's constant, and you can derive mv, that is equal to root over 2m kinetic energy. That is the relation. That is momentum equal to root over 2 into mass into kinetic energy, where mv equal to momentum, k equal to kinetic energy. You know that. Okay. Now we come Heisenberg uncertainty. We can derive, that is del x, that is position, change in position, and del p, that is change in momentum, that should be greater or equal h by 4 pi. We cannot, what is the behind of the concept Heisenberg uncertainty? The concept is we cannot determine the exact position as well and exact momentum simultaneously for any particle, for any moving particle. Okay, we cannot derive it. Their position and their momentum cannot derive simultaneously. If you know position, there should be uncertainty in momentum. If you know momentum, there should be uncertainty in position. So that should be derived del x into del p greater or equal h by 4 pi. Okay. There must be quantum mechanical model of atom, that is Schrödinger wave equation. That is del s square psi by del x square plus del s square psi by del y square plus del s square psi by del z square plus 8 pi square m by h square, not h cut, h square e minus b into psi equal 0. You can derive, that is h cut also here, that is h cut equal to h by 2 pi. You can put on it. Okay, and this equation is 3-dimensional equation. If you want, that is 1-dimensional equation, you can derive only d square psi by dx square plus 8 pi square m by h square e minus b into psi equal to 0 also. There must be x, y, z, they are Cartesian coded. You know that Cartesian coded, there should be, they are perpendicular to each other. That is 3 axes is there, x, y, z axis. Okay, and m is the mass of electron, is the total energy of the electron. That is, there should be v, is not u, that is b, potential energy of electron, and h is the Planck's constant. And psi, that is psi, means that is nothing but that is psi. We denoted psi. That is must wave function which gives the amplitude of wave. This is derived the wave function. If you high study in quantum mechanics or many bonding phenomena or many physical chemistry concept, you have to derive the wave function as a psi. Okay. There must h cap psi equal to e psi. This is, you can say Schrödinger wave equation. Simplest form is h cap psi equal to e psi. You can say this is eigen equation, because when any function that should be act on it and it give the same function again, this is called eigenfunction. And there must be one constant may be generated, and this constant is called eigenvalue. Here eigenvalue is E. Okay. Now H is the Hamiltonian energy. H means if we consider quantum mechanics or quantum chemistry, we what we say E, capital E, as a energy in terms of classical mechanics, and in quantum mechanics we can say as H, that is Hamiltonian energy. Every observable have their parameter in quantum chemistry. Okay, H equal to T plus U, that is must be kinetic energy plus potential energy. Okay, psi can be negative or positive, psi square, but always positive. If we denote the psi, there must be negative or positive slope can be derived, but psi square always positive quantity. You know that if minus 2 or plus 2, they are negative or positive, but they are square always positive. Square quantity, that should be always positive. Okay. Now we consider some orbital diagram. Okay, next one.